Is it recording? Okay. And this is my project that I've been working on in the previous months. Probably it took a while to actually finish this. And I can say that it is worth every minutes and every hours realizing the project because it actually worked. So that's something that I'm kind of really impressed with that. I just works flawlessly with that, the time and effort I, put into making this, but without Dr. Siti Fatima, who am I to actually finish this? So I'm really thankful for, Dr. Siti Fatima to actually help me with, realizing the project as well, helping with every decision and how, the format and everything. So yeah, I'm grateful for that. So without further ado, let's continue with the slides. So to compensate with the slides here to take advantage of the full screen, I have to shut the camera off again because there is a bit of animation going on and there's a bit of like words here that will probably interfere with the camera. So I have to turn on the camera. I turn off the camera right now. So yes. All right. So this is the project. The title of the project, which is Smart Automated Clothesline Retrieval System. So it is about a clothesline, as you can see in this picture, and so let's start. So this is the introduction. As you can see, you can just get a bit of glimpse of what the upcoming things will probably be like, and from the look of the rain and also for the rails. So this project, as mentioned before, it is about a clothesline. So yeah, but firstly, what is clothesline retrieval system and what does it mean by smart automated in this project? So clothesline refers to any type of rope, cords, or twine that has been stretched between 2 points. In this case, it can be sticks or any branches or any poles. Basically, it is located outside or indoors, but usually we found it outside, above the level of the ground. So like in this picture, you can see that this is one types of the clothesline, which is it elevates that clothes and all of their attires here that we have, to dry it. So we have to put it elevated above the ground so for it to have a better drying effect. So it is located outside for the exposure to both sunlight and also for the wind, as you can see for this simple a bit of animations here. um, yeah, the system is called Smart Automated because it is able to work independently based on the weather condition and has an internet connected feature for monitoring the rainfall outside of the house. So meaning that this system is equipped with the ability to actually monitor the rainfall, the status of the rainfall outside. By using one of these application, you can actually monitor that application, which will be discussed later in this upcoming slides. So, but firstly, what actually is the reason for me to come up with this, project? So we move on to the problem statement, which is wet clothes can ruin anyone's good day. This is quite true actually to happening to every one of us. We have probably encountered one of this situation, and it is actually not really something that we are pleased about. So it gets frustrating to know that our clothes sometimes get wet as we are rushing with other jobs in the house or maybe away from the house, like maybe if we are working outside or out and about, which is we leave our clothes hanging outside and we don't actually come back in time to actually pick those up, and that will probably turns out into something that is really like a wet soaking thing. So that's something is really unpleasant thing for us to experience. We can't control the weather, however, we can make it as a game changer. So, therefore, a smart and fully automatic clothesline retrieval system with internet connected feature that can assist job monitoring and keeping our clothes stay dry will be developed in this project. So let's move on to the objectives and what we're about to achieve. So we're going to develop a prototype of clothesline retrieval system with a rainfall alert notification, so we can actually receive the notification from our phones. So the next thing is to propose a clothesline retrieval system that can react to two weather conditions, which is sunny and raining, and to evaluate the performance of clothesline retrieval system in terms of sunny and raining condition. So let's go on to the block diagram of this project. So this is the block diagram. So as you can see, So here we only have one sensor, which is rain sensor, interfaced with the Node MCU, which is one of the microcontroller that is used in this project, which then has the output of the motor, which is the actuators, converted into a mechanical movement. And we can actually receive a notification from the Wi-Fi connected devices. In this case, we can actually be anywhere around the globe, and we can still monitor the rainfall status, for our clothesline at our house. This is basically the general sketches I made. So when it is raining, the red LED lights up and the clothes will be moved in by the clothesline to really save the clothes from getting wet. So this is the explanation of the project diagram. So firstly, the rainfall sensor is placed outside for better exposure to sun rays and rainfall. And when it is raining outside, the motors will move the clothesline in reverse direction under the shade. When it stops raining, the motors will move the clothesline back outside. The built-in Wi-Fi chip connects to the pre-configured Wi-Fi network at home for accessing the Blink server over the internet. So this Wi-Fi configuration is actually pre-configured inside the codes that will later be flashed to the Node MCU. So actually, when the Node MCU is powered up, it will actually connect to the Wi-Fi network of the home shortly after it is powered up. So this is after that, the Node MCU will start sending data read from the rain sensor over to Blink server every 1 second after the pre-configured network is connected. So users logged into the same Blink authentication token code will be able to monitor the concentration of the rainfall in the Blink app anywhere. Other users will probably be able to monitor the same clothesline, which is at home. This is quite versatile for family members to actually share the same monitoring ability, for different person. So when the rainfall reading reaches a set threshold value, an alert notification will be broadcasted to the users. Higher concentration of rain equals to lower value displayed on the meter gauge in the Blink app, and vice versa. An alert notification will be sent to user when it is raining, it will send this alert it is raining outside notification, and when the rain stops, it will send this the rain has stopped notification to the users. So let's go to the methodology, which is the things, the fundamentals that what we are about to actually do here. So this is the flow chart of the project. We will start with the rain sensor. We initialize the rain sensor as the input, the motors and LEDs as the output. So the process is that the rain sensor senses the presence of rain, and at the same time there's a sub process here occurring at the same time, which is the built-in Node MCU Wi-Fi initialization, which indicates by this part here, which is the Node MCU built-in Wi-Fi chip connects to the home Wi-Fi network. So if the Wi-Fi is not appears to be available, so it will try to find and reconnect to the home Wi-Fi network again, and it will loop here until it is until the Wi-Fi is present and it is ready to send data from read from the rain sensor to the Blink server. So after the initialization, it will begin to detect the rain from the rain sensor, which is if there is a rain, the motors will move the clothes under the shade, and it will always loop here to detect the presence of the rain. So if there is no if there is no rain, the clothes will move outside, and that's the process of the system here. So how does the hardware interact with the Blink application in phone? So firstly, the Node MCU is pre-programmed to connect to home Wi-Fi network. So after establishing the connection, the Node MCU is ready to send the data read on the rain sensor to the Blink server. The data transfer rate is defined in the codes for every 1000 milliseconds, which is equals to 1 second. Every 1 second, it will send the data and send it to Blink server. So the data sent on the server is sent to the devices that are logged in to the Blink authentication code set in the code flash to the Node MCU, which is we predefine that the authentication code inside the codes flashed to the Node MCU. So only the users with the authentication code will be able to monitor that rainfall. So the meter gauge in the Blink application will show a low value when it is raining outside. the set threshold for the rain notification to be triggered is when the value falls below 870. So when the value drops below 870, so the system will send a notification to the user's devices. When the value exceeding 880, it will trigger another notification telling that it is sunny outside, which is the rain has stopped showering. So in this case, there's a bit of gap here, to avoid any, like a bit of spikes there, like to increase the stability of the system, because sometimes the system might actually have a bit of in the middle state, they kind of have a bit of changing in instability. So this 10 gap of 10 between 870 to 880 provides us a bit of a stabilization on the system, for the system to not actually trigger between the two, transition between the two, so to have a smooth transition between the two. So it will not actually be stuck or be actually stutter in actually to move in or out when the value is not having any gap at all, because the difference that is for 10 is quite significant. It's quite, I think, quite better actually to compensate for that purpose. So this is the Blink application interface, and as you can see, this is the inventor widget, this is the meter gauge, and this is the notification widget, which is for receiving the notification from the Blink server. This inventor widget is actually like a case statement, like if else statement, like if the rainfall falls below 870, like in this case it will send the rain notification to the users. So, and at the same time, if the value exceeds the 870 on the meter gauge here, it will send a sunny notification to the users, telling the users that it is sunny outside. So this is the use of the inventor widget to create one of these if-else statement inside the Blink application. So when the sensor senses the rainfall, it will send an alert notification, as you can see on the left side here, which is in this case the meter gauge falls below 870 for the value. Another notification is triggered for when the value is exceeding 880, which is in this case it is 1024 on the meter gauge value. So let's move on to the results and discussion. This is the aerial view of the prototype. This is the front angle view, the rear angle view, the front view, the rear panel view. As you can see, there is an indicator here, the right side view, the left side view, the clothesline, the N20 DC geared motor here. You can see this as the actuators that move the clothes in and out. This is one of the crucial parts of the project. So without this, the clothesline will not move at all. Passive rotary pulley helps one of the crucial part as well, to help to move the clothesline in and out. So this is the limit switch to stop it in the desired location, so it will not go far beyond the limit switch. So that's a good something that we really intended in this project. We don't want it to go beyond the limit switch. This is the limit switch located outdoor, and this is the limit switch located indoor. So this is the main board. It consists of the Node MCU and the L293D motor driver. Also, there are two relays connected at the output of the motor driver, which is located here. This is the LED indicators, and this is another look on the indicators. This is another view of the fabricated board. So the Node MCU is, as I said, is actually detachable. So another time, if we want to replace maybe the Node MCU, or if we want to pre-program it again, we can just detach it from the female header socket here. So which provide excellent maintenance if we want to actually, or maybe for another purpose at the same time, for us to actually maybe if we install a new router and we want to actually pre-configure the network connection or other authentication code, so we can actually do that at the same time. So it provides an excellent option for us to actually be able to take it out and in. So at the same time, this is the IC socket for the motor driver as well. So this is the rain sensor. So in this case, we only have one input to the Node MC, which is this rain sensor. So the rain sensor is placed outside for better exposure to the rainfall and the sunny days. So yeah. So that's all. Let's continue to the conclusion. Thank you. So moving on to the simulation part, this is the complete prototype of the project. So let's power it up. So the relays are the first to turn on, and then follow up by the LEDs. So the indicators here tells that it is sunny outside because there is no rain. So the clothes will be moved outside. So if I apply the rain again, and it will change to being from sunny to raining, and the clothes will move in. If I remove the rain, and again, alright, so let's allow it to go outside first, and then we will look into the blink application, and we will trigger the rain and see what the notification will come out or not. So this is the blink application, and as you can see, we have one of these gauge, which is the reading that will actually read the rain sensor here, the value of the rain sensor, and these two parts here is for the eventer, and this is for the notification for us to receive the notification sent by the blink server to us. So if I apply, this is in the play mode. So if we apply the wet tissue, which is, it will indicate the rain, and we receive the alert, and the value will drop. So if we remove this wet tissue, the reading of the rain sensors spikes up, and it moves the clothesline out. So again, if I remove the wet tissue, alright, I think that's all for the simulation, and thank you.